Welcome back. Today I'm going to explain how you can approach a function in terms of a function of a function or a composite function using chain rule. In the last video, I explained how you can solve a derivative in terms of product and quotient. And don't forget I said it is very simple when you have it is very simple to know how to apply quotient rule because you will have your function in terms of what? In terms of fraction. So likewise when you have product, so that is when you have the relationship between your functions, when you have it to be product. Today we are going to continue from where we stop. So we are going to composite function. Remember what I told you the other time, that is when you have your y to be function of a function of x like this. We call this type of function a composite function of functions of functions. If you want to solve derivative, so in this form, then you are going to apply what we know as chain rule. And don't forget, I wrote it for you. If you not watch the video, you can refer to it. I said your dy dx will be, just write dy here, sorry, dx here, then you put du. So that is dy du multiplied by du dx. This is known as chain rule. And how do we get this? You know you have your y is equal to f of g of x, then you make your u to be g of x. You understand now? From there you can find your du dx, then your y will now be f of u. Since our g of x is made u already, then you are going to find your dy du, then you are going to multiply the two of them together. That is dy du multiplied by du dx. If you check it very well, that will give you dy dx. That will give you dy dx. So if this is cleared, let me give you an example to back it up. Example, if y is equal to sine 5x, you know the derivative of sine 5x from the standard derivative I gave you will be what? That is 5 cos 5x. So then the question says you should show that derivative of sine 5x is 5 multiplied by cos 5x. It is very simple. Solution. So you know I have my y to be sine 5x. Are we going to use quotient rule for this? No, trivially because our function is not in form of fraction. Okay, now can you use product? You can't use product because this is a single function. You understand now? How is it a single function? Although 5x is a function, but can you, if for example, if I clean 5x like this, let's say I erase 5x, let's say I erase 5x, what do you have left? Sin. You understand now? It means you are committing sin if you erase it like that. So there are functions that cannot stand on their own except they have their argument, except they have what we know as argument. So when you have this type of function, you know it's the same thing as sine x times 5x. When you have sine x times 5x, you are going to apply product rule here. But this one, it's a composite function. When you have a composite function like this, that is a function inside another function, then what you are going to use, so is known as what? Is known as chain rule. It's known as chain rule. How do we do that? It is very simple. Just take your u to be 5x. That is a function that can stand on their own like this, which is 5x in this case, or the simplest one. Then you now differentiate it. My du dx will give me what? 5. Don't forget from your standard derivative. So now if you go back to your question, my y is sine. Don't forget I've made my 5x to be 8, to be u, right? Then your dy du will be what? What is the derivative of sine u? That is cos u. Then you now say therefore my dy dx, don't forget your chain rule, That is dy du multiplied by du dx. You don't need to memorize it. Just write dy here, dx here, then put du. Okay, now what is dy du? My dy du is what? Cos u multiplied by what is du dx? That is 5. If you multiply it together, it will give you 5 cos. You don't say cos 5 u because this is a function on its own. So then if you substitute, then you are going to have that. So 5 cos, what is my u? My u is 5x. So my u is 5x. If you check with what we were asked to show here, so you can see that we got the same result. You understand? Now that proves what I wrote on the standard derivative, that when you have sin AS in general, then derivative of sin AS will give me what? A cos AS. That's that. Let me give you another example. Number 2. If y is equal to ln 3 minus 4 cos x, find dy dx. Let me ask you, are you going to use quotient rule? No. Are you going to use product rule here? You can't use product rule because you don't have different function. You only have a single function, but a composite function, because it's a function and this is a function of this. Then how are you going to do it? Don't forget the approach is very simple. You make your u. What am I going to make as u here? That is 3 minus 4 cos x, right? Then you find your du dx. If you differentiate this, your du dx will be derivative of a constant is 0, right? Minus what is the derivative of sin s, cos s? That's minus sin x. That will give me 4 sin x. Now if you go back to your question, your y will now be ln u because I've made this to be u, right? Then you are still going to find dy du. From your standard derivative, your dy du is what? 1 divided by h, 1 divided by u. Then you now apply your chain rule. Don't forget dy dx will be what? Dy du multiplied by du dx. And your dy du is what? 1 divided by u multiplied by what is your du dx? Du dx is 4 sin x. That will give me 4 sin x divided by u. And don't forget, my u is nothing but what? My u is 3 minus cos x. I think so. Let me check it very well. Am I correct? Yeah, 3 minus 4 cos x. So 3 minus 4 cos x. So 3 minus 4 cos x. So therefore your dy dx will be this. Can you see it is very simple? And you can see the difference between when you are going to use product and quotient rule now. Quotient rule is you have your function as a single entity. For example, if I have my y to be sin 3s, you can see that you can't split 3s from sin. If you split it, then you are committing sin. You understand? You are committing a sin. So, but for product rule, you are going to have functions like this. So, and their relationship will be what? Will be product. You can as well split them. Sin s, es, cos s are independent of each other. But for quotient rule, it is very simple when you have your function in terms of fraction. So when you understand, if you understand this, please don't forget to like, share. And if not subscribed to my channel, don't forget to do so. I will meet you in the next video. Thank you.